Alright, so picking up on what you guys learned last lesson, we saw this new sort of form of a quadratic, a bracket x minus h all squared plus k, and we looked at the different transformations it created. And the other thing that you saw is by looking at the equation, you could see the vertex relatively easily. So in a situation like this, the h and k value in here actually give you the vertex. And the a, just like in standard form, will tell you the direction of opening as well as telling us whether we were stretched or compressed. Okay, and just for an example of that, we can go back to the example we looked at last lesson. So here, for example, the red one here, y equals negative 1 over 4 bracket x plus 5 squared plus 7, we can sort of see our vertex, right? The vertex is at negative 5, positive 7. Okay, if I change the values in there, let's say I have x minus 4 and minus 6, let's change the values around. Now all of a sudden you can see my vertex is at positive 4, negative 6. So it's the h and k values here that will actually tell you what the vertex is. So you can see as I change h, the axis symmetry moves with it. As I change k, the optimal value here changes with that. Okay, so looking at this one, y equals negative 2 bracket x plus 6 squared minus 11, I want you to take a minute and tell me everything you possibly can about the graph of that parabola just by looking at the equation. Okay, so take a minute and write down all that and see what you can come up with. Okay, so hopefully, looking at that, we should be able to see that the vertex was at negative 6, negative 11, which tells us our axis symmetry is that x equals negative 6 and our optimal value is at negative 11. We should be able to tell it opens down because our a value here is negative. And if you want to look at how compared to y equals x squared, that basic parabola, this would have been vertically stretched by a factor 2 because we have a 2 up there in front of the bracket. Okay, so again, this form can tell us a lot. We've looked at factored form, which tells us the x-intercepts or the zeros. We've looked at standard form, which tells us the y-intercept, and now this one is actually called vertex form, and from the title you could probably guess that it tells you the vertex, h and k. Okay, so let's try and put this into practice now. So let's try and find the equation of a quadratic given some different information. So here I'm giving you the transformations. So giving you a transformation of x squared, so it is vertically compressed by a factor of 1 over 3, translated right 5 and down 9. So just for reference here, let's keep our vertex form handy. So x minus h all squared plus k. Okay, now because we have been translated right 5 and down 9 from y equals x squared, so remember on y equals x squared our vertex is at 0, 0. Okay, if it's been moved right 5 and down 9, that vertex has moved to the point 5, negative 9. Okay, and so that's our vertex now after the transformations, and we know that's going to be the h and k value inside the equation. So it means our h is going to be 5 and our k is going to be minus 9. So right away I can put in that information. I'll deal with the a value later, but I'm going to have x minus 5. And then I will have minus 9. And again, that comes from the fact that I have my vertex. Okay, now as for my a value, well, what's telling me here is that I'm vertically compressed by a factor of 1 over 3. So, and it's the a value that gives me the vertical compression factor. So that will be my a value. So I'm going to have 1 over 3. So I have 1 over 3 bracket x minus 5 all squared minus 9. Okay. And now let's take a look at the next one here. So here I'm giving you not the transformations but the mapping rule instead. So this tells me that all my x values move left 8, so down. So each x value goes down by 8, which again, if you're looking at x horizontal values, that means they move left 8. So this one is going left 8. Okay, we have a negative 2 over 7y, so that means the negative means we have a reflection. 2 over 7 means we have a vertical compression by a factor of 2 over 7. So we can, just from there, get our a value as being negative 2 over 7. Okay, and then we go up 4. So we're left 8, up 4, which again will mean our vertex is going to be at negative 8, positive 4. Okay, so that gives me my a value, my h value, and my k value. So if I wanted to put it into my basic vertex form right here, I could. So my a value is negative 2 over 7. My h value is negative 8, so I have x minus negative 8 all squared. and my k value is 4, so I get plus 4. And what I'm going to do, is to simplify this one over here. Pardon me as I just fix this. Inside the bracket here I have x minus negative 8, which we know when we subtract a negative means we're actually adding. So this becomes x plus 8 all squared plus 4. Okay, so that gives us our equation. Okay, moving on. So now, again, the whole idea behind this is, again, being able to find equations of quadratics. So I'm giving you the fact that we have the vertex at negative 3, 5, and I'm told that this passes through the point negative 7, 4. I want to find the equation of this graph. So we've come up with equations of parabolas before in earlier units, and generally what we did then is we started with the zeros and tried to create factored form from there. Here, I'm not giving you the zeros, although you can see one of them on the graph. I'm giving you the vertex instead. So if I'm giving you the vertex, you would make sense to actually try and create vertex form. So again, using vertex form, it always helps to start with that basic form written out. X minus h all squared plus k. Okay, and again, since we're being given the vertex, we're being given what h and k are. Okay, so we can replace h and k in the equation with negative 3 and 5. So that's going to give me y equals a, and I'm going to have x, so x minus negative 3 is x plus 3. So x plus 3 all squared plus 5. Okay, and much like working with factored form or trying to find the equation, there was a mystery a value we had to solve for, because I can create tons of different parabolas that have this vertex, but only one of them is going to have this exact shape where it passes through that point. So if I know it passed through the point negative 7, 4, what I did before with factor form is I subbed in the point and solved for x and y, and it's the exact same process here. So I'm going to sub in negative 7 for x, 4 for y, and then I'm going to have to solve for a. Okay, so if I do that, I get 4 over here on the left side of the equation. Okay, x is negative 7, so I have negative 7 plus 3 all squared. Okay, and I'm just going to follow order of operations here. So I'm going to work inside the brackets. Negative 7 plus 3 gives me negative 4. And from here on in, it really is just algebra. But it always takes good practice to make sure that we're not making any silly mistakes. So negative 4 all squared is positive 16. So I have 16a plus 5 on the right side of the equation and 4 on the left. So the kind of algebra mistakes I often see a lot. I often, for some reason, see people here try to add 16 and 5 together. And you can't do that because they're not like terms, right? 16 is multiplied by a, 5 is not. So our approach here is to subtract 5 from both sides of the equation. So I have negative 1 equals 16a, and then divide both sides of the equation by 16. So then I wind up with a equals negative 1 over 16. Okay, once I find that a value, I can then write out my equation. So I'm going to have y equals negative 1 over 16, and then again x plus 3 all squared plus 5. Okay, so that's the equation of this particular quadratic, and it is in vertex form. Okay, so last example for the day. I'm going to let you try this one on your own first. So I want you to find the equation in vertex form, and I'm giving you the maximum value, and I'm giving you the x-intercepts. Okay, so take a minute here and try and figure out what the equation would be in vertex form. And when you're ready to go through it together, again, just push play. Okay, so for starters here, you're trying to create vertex form, so I wrote out my vertex form here. Now, normally we want to actually have the vertex in there, so we start off with h and k. Now, I'm going to give you the maximum value. Now, that maximum value helps a little bit. That's the y value of the vertex, but I don't have the x value of the vertex. So a little bit of a conundrum here. I'm not actually giving it to you right away, but the x-intercepts are at 4, negative 8. So remember, the x value of the vertex is also called the axis symmetry. It's that invisible vertical line that cuts the parabola in half. And it's going to occur halfway between the x-intercepts and the Cartesian plane. So if you see here, I have x-intercepts at 4, negative 8. The axis symmetry will be halfway in between. So we can find that by averaging out the x-intercepts. So I'm going to go 4 plus negative 8, all divided by 2. So 4 plus negative 8 is negative 4. Which when you divide by 2 gives me negative 2. Okay, So that gives me axis of symmetry, which then I can use as the x value of my vertex. Okay, so I'll just put that in here. And now I have something I can actually sub in the equation for h and k. Doesn't help me find my a value, but at least gives me a start. So I'm going to wind up with x minus negative 2 is x plus 2, all squared plus 5. Okay, and I want to find my a value. And in the previous example, I had a point that I could sub into the equation. Now, here I have the vertex. I know it's at negative 2 and 5. But I've actually given you guys 2 points you can use. You have 2 different x-intercepts here. So let's say I wanted to use this x-intercept. So that would mean I would sub in the point where x equals 4. And since it's the x-intercept, that would mean the y value is 0. So I can sub in the point when x equals 4, y equals 0. Okay, I could use this one and sub in negative 8 for x and 0 for y there. I'm going to use 4 because it's a little bit of a nicer number to work with. There's no real extra negatives hanging around. So I'm going to have y be 0 and x be 4, so I get 4 plus 2 all squared plus 5. Okay, so simplifying here, 4 plus 2 is 6. 6 squared is 36, so I get 36a plus 5. And just some algebra here to solve. So subtract 5 from both sides of the equations, and then divide. Okay, so that gives me my a value, and then I put that back into my equation, and I get my equation in vertex form. Okay, so with this new form, there's a whole lot of other stuff we can do, and we're going to look at that in the upcoming lessons, but for now, there's some homework there you can work through, and that's it, that's all.